Welcome to this particular topic of how to deal with heat in electronics equipment. As you will find out in the say next around 30 to 40 sessions, it is old, quite old, and even at home we would have felt this problem at two levels. One is in the kitchen where you like to heat something. So, there we have this very simple way of heating something on a flame or on contact with this thing, and latest is being induction. We know how heat is what you call used, and then special cases of if you want toast bread. So, I have a bread toaster in which heat is generated by or there are coils outside by thermal radiation. So, you can see things inside, and two of the new things which have been actually quite around for quite some time is your microwave oven or micro-oned. So, the microwave waves, I mean in a way no, it was a miraculous thing, it has its place, very good for certain aspects and a little bit of something in the other aspects. Similarly, now you have induction heating. While this is exactly in the heating point of view, in the other side you also have seen small cooler which you carry around in your car. It has a Peltier junction inside. So, whenever any electronics equipment does its function, we have a inefficiency in it. First of all, it is quite hot there. So, we would not, when we design a circuit, I do not think we think about that much about how much heat is generated though, but it is hot. All the unwanted thing, the actual conversion of a something into a signal is very little. Most of the other power input goes off as heat. Secondly, whether like it or not, inside the equipment all the time we have a little bit of cold and then we have little bit of hot, and then happily things mixing together. If something is at a steady state, we have no issues at all. But the moment something cycles through hot and cold, we have issues of various parameters including drift, and sometimes the drift is small with a small region and with a short time. So, if there is enough thermal mass, things get evened out. But imagine something heats during some time and then again it cools over a period of time, typically a diurnal variation. What happens in the morning, what happens in the night, and when something is switched off, how things cool, and something is switched on, how things heat up, and the cycling. And imagine this happening over a long period of time. So, if you are to talk about a radio beacon, it is expected to work forever and ever, okay, until it is replaced. And then if you are to look at your own air conditioning in your room, it is supposed to work. Even in the case of human body, when you look at the weather prediction, one of the first things they talk about is what is the current weather, and two parameters you also would have noticed, saying outside the temperature says in our case which a hot place which I come, saying it is 30 degrees Celsius, but then they give a small thing saying it feels like 41 degrees or the real feel is 41 degrees. So, I suggest you read it up. It is all about managing heat or introduction to electronic cooling and anything else including heating. Now, there are three important aspects. It is not as if it does not exist, and in fact if you take any book on this electronics cooling, first thing you will end up is with lot of analytical techniques and methods. I am not saying it is not you can dispense with it, but it is a good place to start. Like all other chicken or egg thing, no, unless you know a little bit of theory, you cannot start with the actual practice. Unless you practice and you have a little problem, you will not get back to the theory. So, but theory has been around. Kindly remember Fourier and several other people now have worked on this for a very long time. The very initial this thing, no, saying you have a thing called a higher temperature and a lower temperature, then you have a flux, we have total energy, and energy in transition has been very old, 200 years old. It is not something which started with the world wars or it started with anything. People were using things, but the theory, no explanation has been there. In this part, a quarter of it or maybe a little over a third of it is going to be a repetition of heat transfer theory. Except that this theory, we try to fit it with known things. Second part, which is prior art, commercial prior art, saying people sell these cooling devices. So, typical best example is a heat pipe or vapor chamber. You cannot fabricate these things easily except for a small experimental application and demonstration. Commercial things have developed over a long time. So, while the first little over a third is about the known analytical theory, this theory is available in other lectures as part of this thing or as in textbooks. I myself recommend what is called Remsburg's book, Fluid Dynamics of Electronic Equipment. I suggest you have a look at these things. So, all the time we have this what I call a fantastic set of theory and various things like saying if the process is frictionless and no heat is exchanged, operate, and these things are very much there developed to a very high degree of certainty. Saying if you know the viscosity, if you know this and then some what is laminar and all that, theory part of it has been there. While this is a book which is convenient and things like this, you can, I feel you should read it absolutely. Then we have fluid dynamics as well as pressure, density and height and so on, all this, enough heat transfer theory. Then commercial prior art also is there. This prior art explains to you saying somebody has been using a heat sink here. You have come across this. Whenever you open a what you call by now ubiquitous PC, except that at the back it is unlikely that you ever opened it and got it up to this point. Neither have you actually broken it out and then tried to show this. And then see for some reason there is something else has happened and you see the way the fins have been made. Commercial or prior art explains to you a little about what is going on, and things like this can probably be obtained off the shelf. So, I will try to cover these things, and then these I am sure you have come across in your circuit level. If you have been working with components, you see that is a very cute tiny heat spreader, and then we have something here, somebody has tried to improve on it by making these things. And I have a just to show you what a device is, and then you see we have all these low power simple heat spreaders which are there. So, prior art talks to you about what is it that other people have been doing. There is an advantage for you, meaning you can go back, come back and then you try to use it. Then try to show you a few of our own examples where we try to do, and then hopefully it will take us to, this is a data acquisition system which one of our research people have done. How we have dealt with the problems that are mentioned here, including I see I have a little higher power equipment, and then how these equipments are mounted and what do you have inside. Okay. Then products where we try to implement these things. Now, one thing I thought I will just sort of gloss over it, saying a product is never in isolation. Typically, it is well said but rarely possible to practice. We do not have the over the wall type of design. It is not as if somebody does one little bit of electronics design and eventually everything comes neatly packaged and automatically something happens. It is, you have to have, you still have to have mixed mode analysis, you have to have everything, but finally as we go down we see that so many things are there. In the end, this environmental, thermal and interconnection is what typically a package is involved in. So, This particular aspect is all about this thermal environment, little bit of interconnection. I like to invite you to this. Only one or two cautionary things here is saying it is not a question and answer session, neither is it a tutorial type thing by which you can pass an exam with it or get employed by it. However, you will realize probably that there is a lot of this theory as well as practice out there. Given a chance and when you need to implement it, it is easy. You can sort out and you can avoid unnecessary experimentation if you are prepared a little for it. So, I would like to welcome you to this session, and then it is unlikely that there are any canned answers for your particular situation. It is for you to go and around search and all that, and I can say, so thank you for patiently watching this introduction, and once as you go through it, I will show you a few of the links directly, things taken from the YouTube, and then things which are taken directly as from the PDF downloads, and PDF downloads are both from the academic community as well as the commercial manufacturers. So, it is easy for you to start off from there. So, thank you. I will stop here, and then next time when the actually full first lecture starts, you will hear a lot more about it. So, thank you.